Hey everyone, I don't know if anyone's out there, and since this is my first big approach to this, I'm not so sure if it's all working like I hoped either. So let's see what happens here. In stream, live stream. Hopefully, I'm in the stream. Hello, hello. Anyone out there? Oh, there it goes. Approach to this. I'm not so sure if it's all working like I hoped either. So let's see what happens here. In stream, live stream. Hopefully, I'm in the stream. Hello, hello. Anyone out there? Oh, there it goes. Approach to this. I'm not so sure if it's all working like I hoped either. So let's see what happens here. In stream, live stream. Hopefully, I'm in the stream. Hello, hello. Hey, bear with me again a little bit. I'm going to put in the chat a link in case you want to join with the video as well. But more than glad for folks to use the chat, raise some comments. Let me paste that, and then I'll present some thoughts real quick. As soon as I find my little link, here it is. Click, 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 click. Okay, so my name is Lester Martin. I work at Starburst. I've been working with Trino and Starburst for the last two years and some change. And before that, I spent 8 years over there at Hortonworks, which then merged with Cloudera. And I've been kind of focusing on this big data analytics space for some time. Hey, I see Evan saying we're out there, and that is awesome. I also wanted to, just kind of have an open mic session here and see where it goes. And what I put in the chat, hopefully, I did put it in the chat. It says StreamYard.com. Don't feel the need to click on that, but if you wanted to join me live, then I would encourage you to do that. What I'm going to do in the background is remove that. All right, there we go. Now, the interesting news, the sad news, the good news is that you are seeing my big head. And I wanted to show, thought I pulled it off. I wanted to, any second, hopefully it'll disappear. There we go. My goal was to show my screen a little bit. I'm trying an application I've never used before other than playing around. And I guess I messed it up at the last second. So that's okay. I have some topics I was going to bring up if we don't have any. But generally speaking, the goal was just to have an open mic conversation. Again, around Trino, primarily Starburst, Hive, Hadoop, Spark, primarily kind of data engineering topics. And I went ahead and put a few topics listed out there, like I said, just in case no one else wanted to bring anything up. We have a whole 6 people now. That's awesome. And let me just run through the chat and make sure. StreamYard, browser-based. Very amateurish hour. So thank you for being here with me. And I don't see anybody chiming in, but I wouldn't mind if you just took a minute for the few folks that are out there, just like Evan did, just kind of put a, hey, I'm out here. And definitely, if you have a question, you don't have to ask it right now. There's Monica. Hey, Monica, this stuff is delayed a little. So I see myself on my streaming software. I have LinkedIn up, and it's about 6 or 7 seconds behind. So it's a trip for me. So this is number one is always a fun activity. Okay, so if you have some questions, I'd love to hear about them, but I did promise to bring a few topics. So at the top up there, it says, if we don't have any Q&A, maybe we can talk about a couple Apache iceberg topics. Why? They're relevant to what I've been focusing on lately. And 2, I think there's some little less known features that I want to make sure we talk about out loud here. I listed S3 access. Hey, Frank from Dell. Frank and anyone, please interrupt. I know Monica and Evan, because I see them every day, and they're being nice enough to show up. Any anything. They're being nice enough to show up, so it's moral support. But again, the goal would be asking Q&A. So I'm going to read Monica's question, then if it's and then I might look at my topics and talk about them. Monica says, any things you can comment on with different query engines on Iceberg? Hey, that's a good one. And in fairness, I think probably for a lot of us, the different query engines that we're thinking about with Iceberg are probably today primarily Spark and Trino. Now we can argue that Databricks as a larger organization, as an organization itself, we can argue that Snowflake with their cloud data warehouse, both are talking a lot about, hey, we can also do icebergs statements, and we can definitely go down that path. And but I want to take a minute and talk about the first part, which was, when we think about Spark and Trino, Spark has, Trino is a SQL engine. Presto, Trino, Starburst. Many ways it sounds and smells like the old Hive framework as a concept. We do everything with SQL. So I think the big differences or the subtlest differences are things that maybe we just haven't tackled yet. A good example that comes up that's very recent to me right now is I did a big presentation on, things that might slow you down when you're migrating to Iceberg. And I made a big stink about, hey, if you've got a Hive table, an external table in Hive, and you're loading it from a third-party process, and that's all you're doing, that's your entire ingestion, loading, and everything model, that table is not going to be a good candidate to come to Iceberg, because Iceberg doesn't do external tables. Iceberg needs to do true managed tables, meaning you kind of have to go to an engine and ask it to load data and that kind of stuff. So what am I beating around the bush? I'm beating around the bush that there's one really cool feature, and there's more than this, but there's really one cool feature that says, hey, Trino can't do that, but maybe Spark can. So Spark community did create more about 2 years ago, looks like, a feature they call add files. So if someone is building not CSVs or JSONs, but they're building parquets and orcs, for example, that align with the schema and everything. So they're very sophisticated data engineering shop that's building data sets that really could just be thrown into your Iceberg table. They raised a lot of concerns and asked for that kind of feature, and ultimately got it. And what happens is Spark is really just taking a look at those files, reading the metadata out of the footers in those parquets and orcs, and then updating the metadata in Iceberg, and then updating, of course, a new snapshot ID, and it all works really good. That one's a big one that we just can't tackle in Trino today. We don't know how to do that because you can't just stick it in the folder. You have to update that metadata, and it becomes a pretty big deal. That might not be what you're looking for, Monica. That's one of those subtle differences that could be big. I still stand by my statement that if you have a third-party system loading your Hive table, chances are it's not loading it as Parquet. It's probably coming in as CSVs or JSONs or something like that. All right, so there's some things there. Yeah. What else you say, Monica? What's the difference between with compute on each? Help me out trying to make sure I'm understanding what we're thinking about there, Monica. So you're talking about, say, Spark SQL, Trino, and are you asking what are the engines doing a little differently when it's an Iceberg table, or are you asking something slightly different than that I'm missing? It's fun to watch myself in a more like 10-second delay. I'll wait for Monica to kind of help me out with the question a little more, but I will transition and talk about those other two topics listed, at least at the top of my screen. That says, oh, there we go. Do they optimize Iceberg differently? I don't think that. I think the answer is no, but like I said before, sometimes maybe Spark is a little ahead. We're talking about more advanced features, meaning things like Spark in its rewrite operations. So if you're familiar or not, Iceberg has some cool rewrites. You can say, hey, basically optimize this stuff, or force a compaction where it looks at files and rewrites them, and we get fewer larger files and all that good stuff. There are cool features in data lake tables like sorting, and the more advanced ones like Z ordering, like Bloom filters, and the equally cool, or probably more cool, more useful things like partitions and buckets. Those happen as you insert data, no matter what. Sometimes Bloom filters work that way, but Spark does have some sophisticated features that say, you know what, it's rewrite time, and I want to apply some sorts. I want to apply some Z ordering that we just can't do yet today in the Trino engine. So they can, via that framework, knowing what the use cases are, knowing what we need the data. So this is a little bit more than just basic, hey, how would it work faster? You're aware of what you're trying to do, and you can put a little more smarts in that data engineering pipeline to come back. Maybe if you're partitioning at a day level or something, maybe you let the day finish out, and then you say, hey, I'll kick a job off at 2 a.m. It looks at yesterday, and it forces a rewrite, and then you do all the nice things that we can easily do in Trino, compaction, rolling together delete files, all that. But you can also apply like a cool concept like a Z order, and we just don't do that yet today. So there are some things that will optimize it differently, but I wouldn't say just generally no. You'd have to go out of your way, specifically ask for something. Cool stuff. Okay. I should time myself when I clap and watch how long it takes to show up. Thank you, Monica. All right, I was gonna show. I think what I'll do is put a link, because for some reason, like I said, I messed up on my screen share. I'm gonna fix it next time. I'm gonna paste a quick link in the chat, and I hope everyone takes a moment. You know what? I'll even go a little deeper. Open image and new tab. There we go. I would encourage folks, if you can, pull this link up. This is one of the two topics I wanted to talk about today. And since I'm not screen sharing, I'm looking at that link myself. It's a picture, and I took it out of context. It's from a blog post I did, but I really wanted you to focus on just that picture. And that picture says, hey, guess what? When you use Iceberg, and we're going to focus on Amazon's cloud, but the cloud object stores, when you focus on an object store as opposed to something like HDFS, then moving from something like Hive to Iceberg can really significantly save you some money. And I want to talk about this. Why? Because when I joined up here and really started looking at Iceberg in earnest, I had some doubts. You're like, is that really going to make that much of a difference? So you have that picture there, and it says, hey, AWS lists costs for this particular company. It was at Iceberg Summit. It was CrowdStrike, I think. They said, hey, our cost went down 10x. That's cool for list operations. And then they said our get operations, I think they said those went down like 25x, and then maybe like 10x for the gets. So I have to give you a little backdrop first to make sure we agree, and then I'll tell you why Iceberg on a data lake, on an object store data lake, is really going to save money and perform a lot better than using something like Hive on that exact same data lake. You might say, what's the difference? It's just a data lake. Here's why. Apache Hive, in concepts like partitions or whatnot, or the table and the partitions are stored in the metastore, the catalog. And they're just lists of directories. So if it's unpartitioned, hey, here's a directory. If you're partitioned by day and you've got 2 years of data, whatever that is, a little under 800, 750-ish folders. And what happens when the engines run in the old school Hive on Hadoop, it wasn't a big deal, because what they could do is they could say, hey, the Hadoop file system, tell me the contents of directory 1, directory 2. So maybe they did a query. They're looking for 90 days of history. We've got years of history, and partitioned by day. So what we have is a list of 90 folders. That's what the Hive engine would ask us to do. And we get that, and we have to ask 90 questions to the file system and say, give me a list per folder. And the good news is that system works fine. That's all in memory. It's a hierarchical file system. It happens very, very fast. But when we transition and move the data out of HDFS and put it on the object stores are not hierarchical file systems. They are key value stores. I know everyone's heard that, but let me just say it. They don't have folders. You can go into the GUI and say, and if my screen share was working, I would do that. You can go in the GUI and say, create a folder and create a subfolder, but they're not really that. All it's doing is putting a slash and a name in the key itself. So what has to happen in an object store, and the reason why that company, for example, said, hey, we've got 25% less involvement is when Hive runs and I get those 90 folders, it has to do a list operation for each one of those. But he says, you know what? Hey, go look at all the keys you have in your key value store and find me all of the keys that start with or prefixed with, and you give it that folder name basically. And that has to kind of look at this big chunk of keys that it keeps track of and then parse through that. And that's not really an efficient use of how the object stores work. The key value stores like to say, get me this, put this, gets and puts on keys. So we spend a lot of time and effort doing that. And that alone is dramatically different in our good friend Iceberg. Why? Because Iceberg stores in its metadata, which is really in some Avro files on the file system, on the data lake. They have these Avro files that tell them the exact names of every single file. So they don't really have to do those list operations basically at all. They just say, hey, here's all the files I need. And they do much more efficient gets, because we still have to do it in the Hive model. Once we get all these thousands of files, we still have to do gets for each file. But this model, we can just go straight to the gets. And that significantly, what did that picture show? I'm going to look at it one more time. I think they said, list calls for them. You can see Hive, boom, falls to basically nothing on Iceberg. So their list calls overall and their expense drop dramatically. Why? Because Iceberg doesn't have to do all those list calls at all. It's just the feature of the benefit of the framework itself. All right. I'm monologuing without my screen share, and I had it all set up. I got my Apple pencil here. Why? Because I got my iPad here. I was going to draw like crazy and have fun, but that just didn't happen. All right. Hopefully there's some folks who you're not asleep yet. You're still out there. I haven't heard anyone chime in. So I'll tell you the second part of that story. That story shows, in addition, there's a question, Evan. Let's see. So the parsing emulates a folder structure, but still requires list calls in Hive, but not an Iceberg. Yep. Exactly right. So Hive, in its metadata, tells me a list of folders. And from there, I've got to go determine. And that's okay. You have to go figure it out what it is. And Hive, with old school Hadoop, coupled technologies that made sense when they came out, that's not an issue. Just not an issue. No reason to do the opposite. It worked fine. But as the world moved to those object stores themselves, that became an issue for the very reason you said, hey, there really isn't a folder structure. There's a pretend folder structure, and the equivalent of list me the contents of directory. An ls command, like you might do in Linux or Unix, isn't, easy and cheap. So it adds up. Okay, cool. And then Iceberg just says, hey, we know this by default. We know that's going to be expensive on object stores, so let's tackle that up front. Good feedback. All right, the other part of the story, unless someone chimes in and says we reduce get calls. Get calls are, okay, now that I have a list of files, say I got 10,000 files, how do you get a file? Well, you call back to the S3 system and you say, get me the file that is at this key. So it's going to be like folder, myfile.parquet, whatever it is. And it's going to fetch that data, or maybe even more strategically fetch bits and pieces of it if it can. So how could that drop down? Well, that's going to drop down because Iceberg, in addition to storing all those cool lists of files, it's remembering a lot of cool things. So let's think about what that really means. It means that when we start to use columnar stores like Parquet and Orc, those files themselves have some statistics. And I'm going to just focus on a real easy concept. Column by column, they know things like mins and max values. Mins and max. So if I've got a folder, those 90 days we talked about, what if what's in there is phone records, phone calls, and activities based on phones? And what if for a day, I've got thousands of files, but what if I, in that process of once, the following day compacting and stuff, what if I applied to one of those sorts that we talked about? Then what's going to happen across my 1,000 files roughly is going to say min and max. I've got phone numbers that start with 1 to 2, and this one says I got 2 to 3, and this one says I got 4 to 8, and this one says I got 8 to, so they start to create kind of banding, kind of layered banding or ranges that fit together nicely. And why is that important? It's important because Hive itself can benefit from that. Hive can say, hey, you know what? A Hive table can say, cool, now that I have a list of the files I need, as I go look at them, I can check their min and max if I have a predicate, if I have a where clause in line with that. And if so, what they do is they just abandon early if they identify there's just no way the phone number I'm looking for is in there. So Monica's on here. She's from Dallas area, Plano. I grew up in Fort Worth, Texas. So Fort Worth used to have 817 area code. So if I sort my phone numbers across 1,000 files, my hunch is the 817 numbers are around 80% through the mix. That may not be real, but that sounds logical in my head. And then a lot of the records, a lot of those files won't have any 817s. Chances are, if I only have 1,000 files, they're only going to be in 1 or 2 files anyway. So the Hive world works really good with these column of files because we can peek into them, read their little statistics, and then go, I don't need to look any further and walk away. So that's awesome, but how can Iceberg help in that get conversation? Well, Iceberg can help because Iceberg, in addition to keeping track of the names of those files, is keeping track of those statistics that are in those files along with it. So they're duplicating that information. Won't cause a problem because it's immutable data. When the file is written, we know that metadata. We can put it in the file level metadata. We can write it in the metadata that's tracking the files. And then what happens? Well, great. We eliminate the lists. We talked about that. But then we can do that fail fasting a whole lot quicker now because I grabbed one file that has all that metadata in it, and then I can parse through that really quickly and identify, only file 750 and 751 could have your 817 phone numbers you're looking for, Lester. Maybe I'm just trying to get all phone numbers, doing an average on any phone number starts with 817 or something like that. So that benefit of that metadata, knowing about the files and knowing about the statistics in the files duplicated there, prevents me from having to do the get itself. So if I look back at that effort, they said, yeah, great, my get calls went down by 10x. I would say, depending on what you're doing, that could go down a whole lot more. And this is their just spin. They didn't take a table, they didn't take a use case. They just said across the board, when we went to Iceberg, we saw these benefits. And while that may or may not have been all that exciting to everyone listening in, I would say that was an area that when I first started with Iceberg, I had like I said, some doubts, some concerns, and I said, I doubt it. And then I did a bunch of testing, but I was still not really seeing that impact. But that really came down to the fact that I wasn't, pushing it to the nth level either. I was trying to save some money and not run the biggest environment. But I'm happy and thrilled to see that the theory, the practice is really what happens at size and scale in organizations. So Evan, who's a colleague of mine, so nicely said it in one sentence, my rambling in 5 minutes. Absolutely. That additional metadata collected by Iceberg is going to speed me up. It's going to let me fail fast the same way, but not having to look at the files themselves to find out if I can fail fast. And if that was a folder full of 1,000 files and you had 90 folders, that's 90,000, 100,000 files that I don't have to make 90,000 gets. In fact, if we said it was on 2 files per, then I'm going to make 180 gets to the files that probably have my 817 phone numbers, and I can skip the other 89,000, the other 90,000 files. So absolutely can save a lot of time, a lot of focus, a lot of effort. Cool stuff. Okay. All right. Yeah. In fact, I'm having a chat session on that very thing in the background. Just noticed a colleague of mine didn't know it though. Okay, so I have 25 after. I got five more minutes in my inaugural Live with Lester. I lost somebody along the way. I see 5 participants. Thank you for whoever was here and moved on. I get it. Hopefully I can do this again. I have one more topic I want to run through real quick and just talk about it briefly. And the best thing to do is do what I did before, send a link. So I'm going to send this very link right here into the chat. So please, if you got a second, please visit that. That's going to take you to a SQL file. So a GitHub project there. And it's part of a demo, some demos I did in another webinar. You're welcome to, when you're there, you can find the links and all that good stuff about that demo. But really what I wanted to focus on there in that, so I'm going to pull it up on my other screen, would be lines, lines, look at lines, I'm going to call it 173 through 176. So 173 through 176 are how Hive tackles, I guess I'm talking, I don't have to type, how it tackles what we call bucketing, sometimes called clustering, aka clustering. With 3 minutes left, the crash course is, what does bucketing do for us? Bucketing says you pick a field that's in this table, and you tell me how many buckets to create, and what I will do is guarantee, I'll do a hashing algorithm that guarantees that all distinct values, every row with a distinct value that I'm bucketing by. So it could be like in this case, I think it's an order table, and I'm bucketing on the customer. I'm going to guarantee that all the customers of a specific customer land. I got a real question. Awesome. I'm going to take a look. Let me just see if I can knock this out, Frank. They're going to throw all that in there and say, hey, great. They all fit in this file, and move on. So bucketing, that's the way Hive does it. In fact, it does it. It implements it as a file. So likely you're going to do partitioning and bucketing. And since I'm running out of time, I'll also say take a look at rows. Looks like 184 through 186. Boy, I really should have got my screen share working today. This is how Iceberg does it. And what they do is they actually say, guess what? We don't do bucketing, but we will let you do a helper method. So they do these cool helper methods that are available when they do partitioning. So if you look really close to that last line, it says something like partition by, order priority, and bucket, customer key 5. So what they do is they actually do the same concept, but they actually do create a folder with that bucket number. And again, it's out of time, so I don't want to go into too much detail. But they're fundamentally doing something. They're fundamentally doing something different, but they're fundamentally doing the exact same thing. Technically, they're doing it differently. Semantically doing it different, but the benefit is the same. If someone's looking for that specific bucketed value, the engines can say, oh, great, look at files that start with this name, or in this case, with Iceberg, look in these folders. So something worth looking at. All right, Frank was here, had a question. And when encountering queries that take time, what would you look at to change/improve it? Would you look at more ways to compute, improve the query, change the way the data is next? The short answer is yes to all the above, Frank, but here's what I would do. First and foremost, I would learn how to get a peek at that query plan. Why? Because the query plan is going to show us the stages that are occurring in our query, our DAG, or a whole process there. And not only will they show what those processes are, what those steps are, they'll show you where all the CPU time is happening, even down to a nice percentage. So quickly let me focus in on, hey, what's really the thing that's a bottleneck here? Chances are, a lot of times it's going to be toward the very beginning, which is the bottom. It's going to be around when it has to go read things. And if so, often that's where we have a lot of chance to easily make improvements. And often those improvements, there are a few more things we could start to look at. We could determine if there's a lot of latency, which would imply that maybe the files are too small and those kinds of things. But absolutely, let me just step back and say, of course, no matter what, you can always throw hardware at something and see if that helps. That's not an easy solution for all of us, But the truth is, we need to figure it out. And there are going to be classes of problems. One class of problem is the data just is tough to read at size and scale and those kinds of things. If that determined that's in good shape, so again, column or file formats, bigger, chunkier files, good use of partitioning, maybe those things I just mentioned like bucketing and other such activities. If we get that out of the way, and there's statistics so the CBO can, there's things we can look in there. There are comments that let us know there's a problem, that kind of stuff. So the short answer is I'm out of time, so I'm going to see how long before it kicks me off here. But yes, there's a couple different things we can do. And like most frameworks, you just got to start building those heuristics, how you tackle it. But I quickly will say it again. The query plan does tell us where the high poles of the tent are, I guess you could say. What's taking a lot of time, because sometimes our heads tell us, oh, it's that complex windowing function that I do a ranking. And if you find that in the query plan, you might go, oh, that takes 2% of the whole job. So I'm going to ignore that from now. So it's finding out what's kind of burning things up first and then trying to figure out what's next. And I almost always like to make sure the data is retrieval, because we separate storage and compute, and that's always going to be expensive. Anytime we have to move data across the wire, it does pick up, make a difference. All right, so we can talk about that. In fact, we're working on a master class that will probably offer us some recordings or something in the future. That this is just some of the early topics. We'll do probably about an hour or 3 of different things. So Ryan, Frank, thanks for asking, and feel free to ping it back if you want to go into a little deeper. Hey, David, what do you got here? Thank you for hosting. Thank you for being here. There's down to only a few of us. You spoke on many of the topics I was interested in. Hooray! That's good news. Apologies. I've been listening only mode. No worries. That's all we want. That's good enough. And for a topic next time, great. I'd be interested in hearing about various data ingestion patterns, especially when we don't have much control over the data sources and when to use which data formats. You know what? That's a good thing for me to screenshot right there, David. All right. It's on my desktop. Thank you for sharing that. I probably won't go into it right now. Yeah, thanks. The thumbs up. All right, I think I'm going to wind it down. It's 3:33 here on the East Coast. Did this go great? Did it go bad? I don't know. It was an experiment. I'd love to look back when I'm at the Live with Lester number 100 and laugh about how rough this one was. You can say you were there, because we'll go past the 6 or 7 participants and we'll have 16 or 17 by event number, episode number 100. But, everyone has to start from somewhere. And you guys for dialing in and listening and asking a few questions and just letting me ramble and listen made number 1 possible, and to me a big success. So I'm going to say, as a U.S. Army veteran, thank you so much for your time and attention. Ping me directly if you have some more topics, if you think it was worthwhile, or if it was just terrible. Yeah, it's in the ground for 100,000 options for Evan. Yeah, there you go. And I forgot to mention at the top, Dan Anderson offered up $20 if anyone can stump me. So I'll say, probably I didn't answer everything perfectly to anyone's satisfaction, but I don't know if anyone stumped me. So no $20 today. I'll see if he wants to roll over and make it 40 next time. Thank you all so much. I'm going to disconnect. A big shout out from Atlanta, Georgia. Thanks again for your time. And I hope it was useful, interesting, and maybe even entertaining. Thanks again. Bye.